Good afternoon to all. Uh, Today, for this session, we have Dr. Vyas Pandey as a resource person. He is emeritus scientist of ICR at this university, at Anand Agricultural University. He was a professor and head Department of Agricultural Meteorology for about 12 years, from 2005 to 2017. He served Gujarat Agricultural University and now Anand Agricultural University for about 35 years. His career was started in this university in 1982, and he served till 2017 for in various capacities at different positions. He guided MSc and PhD students of agricultural meteorology and monitored about 20 research projects that is funded by different government agencies like DST, ISRO, IIT, Ministry of Earth Science, ICR, and IMD as a PI and co-PI. He has members in panels of experts in various committees of UPSC, ICR, UGC, SIUs, and government of Gujarat. He has published more than 175 research papers in national and international journals. He is recipient of various academic awards, including Government of India Bronze Medal for E-Krishi Kiran program, that is program of soil health card. He is founding member, secretary of Association of Agrometeorologists, publisher and managing editor of Journal of Agricultural Meteorology for about 20 years. He is reviewer of about 25 national and international journals. He successfully organized various workshop, training program, and national and international seminar symposia. Presently, he is also president of Association of Agrometeorology since 2019. So I request Dr. Vyas Pandey to continue this session. Sir.
Thank you, Dr. Manoj. It's a good afternoon to everyone. It's a great opportunity to share my thought with all of you. As you know, the topic given, that is impact of climate change on different crops in Gujarat under different climate projection scenario. During 1 week of program, you might have gone through the different approaches being used for climate projection and what is the risk involved in the climate. Now, for general information to all the members who are not from meteorology background, I will give some introduction about this climate. As you know, the Earth is the only planet known to support the living organism. Earth's surface is composed of 71% of the water. Water is necessary for the life, and the water actually oceans mostly, which maintains the Earth temperature. So this is the unique feature of the Earth that is make us live and provide the favorable atmosphere. As you know, over the globe, because of distribution of the land, ocean, and movement of the sun, we have different types of climate and vegetation type. In tropical region where the sun is overhead, we have tropical forest, wet dry forest. In dry region, where are some regions are dry, where we don't get any rainfall, then moderate climatic regions are there, and continental climate. So over the earth as a whole, we find different type of vegetation in different depending upon the climate type over the globe. As you know, because of this movement of the sun from 23 degree, 23 and a half degree north to 23 and a half degrees south, as over the equatorial region, we are getting maximum rainfall. And you see, over the year, over the different months during the year, rainfall pattern is also uh, different. So, over equatorial region, we are getting throughout the year rainfall. If you talk of India, you see, we are confined only during June to September. Most of the regions receive, of course, South India also received during uh, because of southwest monsoon during winter season. So therefore, over the year, different regions are getting different amount of rainfall. Similarly, temperature during summer season, where in the northern hemisphere, summers in northern hemisphere are more warmer. During winter season, northern hemisphere is colder and southern hemisphere is warmer. So therefore, temperature pattern also varies over the year from month to month. So then what is the climate change? Actually, this variation is also there. And from time to time, 1 year temperature may be higher or lower, or rainfall in particular season or month or a day, it will be fluctuating. So there are two terms commonly known as climate variability and climate change. Climate variability is a term to describe the variation in the mean state and the other characteristics of the climate in all the spatial scale, whether it is local or over the globe or over the state or over the district or over the talca. Climate variable may be random also, or it may be periodic. There are climate variation over 10 years period. There are some features are there after every 10 years like that. So some periodic variation is there, just like a rainfall in different seasons we are getting. So that variability is there. Then climate change is specifically change due to anthropogenic change. Actually, there are climate changes, other regions are also there, but it is mainly because of the anthropogenic changes. Anthropogenic climate change is caused by human activity as opposed to the changes in climate that may have resulted as a Earth's natural process. In natural suppose because of volcano and all other there are solar activities are there. So their climate change are also due to that one. But most of the things which are changing because of the anthropogenic human man-made that is called climate change. The term climate change has become synonymous with the anthropogenic global warming. Actually, most of the people are talking of global warming. Global warming, of course, it was there, but because of the global warming, there is a change in the uh, everything else because of the concentration of gases, and that affect the not only temperature but all the other factors or weather parameters. Climate variability and climate change. Actually, you see, over the period of time, when suppose this is the trend of temperature, so temperature is decreasing over the this is the climate change, long-term changes. The trend indicate the climate change. Whereas within the year or within a period, there is a fluctuation of this actual climate over the mean value. So this is called as a variability, whereas the change over the period of time is called as a climate change. So this we have to think in mind. Now for general people, you know the sun is the main source of energy. We are getting solar energy in the light form or short wavelength. Some part of this is reflected back. Some part of the whatever energy we are getting from the sun is reflected back, and short wave reflected short wave radiation, what we call albedo. but most of the part which is absorbed by the Earth surface, and because of the Earth surface, Earth absorbs some temperature increase. But when this Earth emits long wave radiation, this uh, atmospheric gases and greenhouse gases, what we call greenhouse gases, they absorb, and these gases emit the radiation in all the direction, and that includes the Earth. Therefore, because of the irradiated radiation from the means greenhouse gases, which absorb the long wave radiation and irradiate in all the direction, then because of this, the temperature of the atmosphere or Earth increases. So this is called as a greenhouse effect. These are the major greenhouse gases. You know, carbon dioxide is the most important, methane, then nitrous oxide, chlorofluorocarbon, ozone, and water vapor. These different gases have different potentials to affect the climate, and they have a, different absorption pattern of the long wave radiation, and because of this, the heating effect or warming effect of these gases in the atmosphere is different. Here you see the radiative forcing component, means how much these in the atmosphere, whatever components are there, how much they are able to increase the temperature. That is what we call radiative forcing. The carbon dioxide, you see the maximum effect of the carbon dioxide concentration, then methane is there, nitrous oxide there, and other halocarbons are also there. Ozone, we have ozone in the stratosphere and in troposphere also. In stratosphere, as you know, the ozone react with the ultraviolet rays and absorb the ultraviolet rays, and and disintegration, formation of ozone and destruction takes place. And in that way, it absorbs harmful ultraviolet rays in the stratosphere. And this has cooling effect on the Earth's surface temperature. But when this ozone is present in the troposphere, then it is having a warming effect that increase the temperature. There are also water vapor present in the stratosphere, which causes warming effect. Then carbon dust, these are also having a, heating effect, warming effect. But land use pattern, because of vegetation, it is having cooling effect. Aerosols have a positive effect that reduce the temperature. Solar irradiance, because of changing in solar, it is having a warming effect. And overall net effect, that is anthropogenic, because of the human man-made. This you see, this is the net effect of anthropogenic region, which is warming the atmosphere. Now, for general water, these are the five key indicators which signify that climate is changing. Carbon dioxide concentration over the period of time, global surface temperature, Arctic sea, land ice, and sea level. These are the five indicators. These are all available. And you see the carbon dioxide concentration is continuously increasing. And at present, it is 415 ppm. Now it has reached. So this is the level of which was pre-industrial. It was about 330 only, but now it has 415 ppm. Similarly, over the period, temperature has increased by about 1 degree, 0.99 degrees Celsius from the mean temperature during 1951 to 80. So therefore, this indicates even 2016 was the warmest year, and last 20 years since 2001, the most of the years have been the record. Means, most of the years have warm increasing temperature. Arctic sea ice, you see, it is decreasing at the rate of 13.1% per decade uh, over the area. And I see over the land, it is reducing by 145 billion metric tons per year. So this is the rate of decrease of ice over the land and over the sea. And as a result of melting of the ice, but natural that sea level is rising, and at present it has increased by 95 millimeter. So therefore, this all indicates that our climate is changing. Now, there is a complex relation between the whatever the climate atmosphere is behaving and what human system is working over the land. In climate, as we have seen, the atmospheric composition of the gases are changing and that are affecting the climatic pattern. So because of the that climate change happen, temperature changes, precipitation pattern changes, sea level rise, extreme events increasing. So these everything is related, interrelated. Means the climate process driver, and because of green concentration of greenhouse gases, temperature changing, and this also adversely affect this one, the aerosol and greenhouse gases composition of the atmosphere, which affect the work as a climate process driver. So this is related. And what is the impact of this climate change, increase in temperature or precipitation? What is the changes in water resources, ecosystem, food security, and society and human health also. So, and on other side, when our human system, socio-economic um, is there, how we are responding to this one, how we are taking adaptation measure, and how we are mitigating. So this all the uh, four systems are quietly interrelated and affecting one another. One side, climate affect society, and society also affect the climate. So that's you can see, and it is a quietly interlinked process, earth system and human system. Now, in order to study how much, what would be the climate over the future, IPCC, and over the period of time, there are many IPCC reports are there. But latest one, they have defined this, what is the future, how the, in future, how the climate will behave. So they have considered the representative concentration pathway, RCP, what we call as a RCP. RCP are consistent with the wide range of possible changes in future anthropogenic gases, greenhouse gases emission, aim to represent atmospheric concentration. Means what we have seen in previous slide, how human system is interacting with the climate system, and whether how much we are adaptation measure we are taking or mitigation measure taking or reducing the emission of the greenhouse gases, what controls are being taken. So assuming all different possible scenario, uh, four scenario has been defined. Uh, that is four RCPs, namely RCP 2.6, 4.5, RCP 6, RCP 8.5 are leveled after the possible range of radiative forcing value in the year 2100 relative to pre-industrial values. So these are means they will having a warming this extent of heating effect over the earth as a whole. In 2.6 RCP assumes the global annual greenhouse gas emission will be maximum by 2020, and thereafter it should decline. And then another scenario I assume that in 4.5 it will the peak of greenhouse gas emission will be in 2040, and after that it will decline. And RCP 6 the peak will reach by 2080 and then decline, and RCP 8.5 it will be there will be no end. So this same thing is shown in the graph. You see this is the RCP 2.6, RCP 4.5, sorry, RCP 6, and this is the where there is no control. It is increasing continuously, the RCP 8.5. So based on this scenario, climate scientists have projected what type of climate would be. And there are various models which are working or simulating the impact of this one over the future scenario. So you see minimum, there are different models, and you see the range under 2.6, this is the range of prediction by 2100, how much increase in temperature will be there in RCP 2.6, means which assumes that in 2020, after that there won't be any increase in the greenhouse gas emission. There are it will, even if we assume that by 2000 this year it is the maximum emission of the greenhouse gases, even then we see that it is going to affect that slightly temperature will increase, and thereafter at the end there may be slight decrease. Otherwise, the temperature will continue to increase even if we stop the greenhouse gas emission as of now. And under extreme condition, you see the temperature of 4 degree, even up to 5.5 degree global temperature is going to increase. So this is the similarly mean sea level that is also having very severe effect because of the climate change, and it is under extreme condition it is going to 1 meter. You see 1 meter is a quite a point 3 meter to 1 meter, the range of projection of the impact of climate change over the globe as a mean sea level will rise. Then rainfall pattern under 2.6, it is also some area, most of the area getting higher rainfall into a surface temperature. It is over surface temperature itself uh, increase, and you see some area you 9 to 10, 11 degrees Celsius temperature are being projected over the polar region. This is the rainfall. Rainfall is highly variable, and you see somewhere it is a decreasing trend. This color indicate the rainfall will decrease, whereas dark color is indicate that rainfall will increase. So the effect of temperature, we have seen the temperature is going to increase over the most of the part, but rainfall in some region it is going to decrease, and some region it is going to increase. Now let us come what we have worked out at Anand, and climate projection and its effect impact on the different crops of the field in the Gujarat. We have used a regional climate model. Uh, the data we are downloaded from Indian Institute of Tropical Meteorology. There is a Center for Climate Change Research at IITM Pune. So through website you can have interact, anyone can get. We used only two scenario data, 4.5 RCP, 4.5 and 8.5, and data we downloaded from 2006 to 2100 for all the districts of the Gujarat. Uh, the annual mean temperature, maximum rainfall, and sunshine, and both the we are derived from daily data, and trend lines have been studied. These data we are formatted for the purpose of using simulation modeling, and we use the DSET group of models for studying the impact of climate change on the different crops of the Gujarat. These are the different districts and the station latitude, longitude for which we downloaded the data for our study purpose. You see, the temperature, maximum temperature, minimum temperature, rainfall, and sunshine. What we have observed, this is the projection of the temperature climate. Under red color indicate the RCP 8.5, and this lower one is the RCP 4.5. The temperature, this is the maximum temperature. Maximum temperature is also projected to increase, and the minimum temperature is also maximum temperature under 8.5. It is increasing at the high rate, whereas maximum temperature at RCP 4.5, it is increasing at slower rate. The same case is observed in the case of minimum temperature also. Of course, there are year-to-year variation. It is not a continuous that temperature is increasing. In one year it is increasing, other decreasing. So that type of variability is also observed over uh, this century. So this is the case of maximum temperature and minimum temperature for Ahmedabad. The rate, this is the equation that is showing the rate of change, 0.2 uh, and 0.6, 0.58, and say 0.6, you can say this 0.5 per year, it is temperature is increasing. Under RCP 8.5, the temperature is increasing at higher rate than at the 4.5. Rainfall is really very highly variable fluctuation, and over the period increase is very marginal. It is not that much what we have seen in the case of rain temperature. Temperature is significantly increasing continuously. Here, highly fluctuation is there, variability is there, but overall marginal. Under 4.5, there is no change. Very minor 1 millimeter, whereas in 8.5 under RCP 8.5, slightly higher rate of increase is there. And sunshine hours, bright sunshine hours, it is projected to decrease. We have noticed in every district the temperature, sunshine hours, bright sunshine hours is projected to decrease continuously, and more or less for both the scenario, under both the scenario, the rate of decrease is slow, but continuous, it is decreasing. This is the case of Anand. We have worked out for all the 24 districts stations for Gujarat, and the in scenario more or less pattern is also more or less similar. Of course, the fluctuation variation from year to year is quite different. It is not in particular year here the lowest temperature is there, Ahmedabad also, so it is not there. Every station is having different variability, different patterns, and but the rate of increase, both temperatures are increasing. Maximum temperature, minimum temperature, under both the scenario, rate of change of maximum temperature under RCP 8.5 is higher than RCP 4.5. And same case is with minimum temperature. Of course, the rate of change of minimum temperature is less and the rate of change of maximum temperature is higher. Same case with the rainfall in the Anand also under 4.5 there is no change uh, and more or less constant and RCP under RCP 8.5 it is slightly increasing at there. Whereas the minimum sunshine hours is continuously decreasing, but the rate is very slow but continuous. Similar pattern for the North Gujarat, highly variable rainfall and associated with the sunshine hours. These two parameters are highly variable during the years. Whereas temperature is also varying, but some, suppose in Junagadh, the variation quite distinct. Minimum temperature is quite distinct, and whereas uh, maximum temperature there are increasing trend, but um, same pattern is there. Uh, High rate of temperature in Junagadh also in RCP 8.5 and lower under the RCP 4.5. So similar pattern has been observed in the whether it is South Gujarat, Navsari is the South Gujarat. Of course, here the fluctuation, year-to-year fluctuation in the temperature is less than the other part. But the rate of increase, that is a zero point 0.2 degree per year, 0.02 degree Celsius per year under RCP 4.5 and 0.5 zero point 0.5 this under RCP 8.5, the increasing temperature. Rainfall, of course, Navsari is also highly variable. Although it is heavy rainfall region, but still we are and the projected rainfall is going to be 5,600 to 1,100 like that. So a lot of variability in the projected rainfall is also in the South Gujarat. Here we have plotted the map showing the rate of change of this is maximum temperature under RCP 4.5, the maximum temperature under RCP 8.5, minimum temperature under RCP. So this red colors indicate the higher. There is no higher, but only among the different districts of 24, we have a slightly differentiated the rate of increase is higher in these districts, Kutch, Banaskantha, Mehsana, Bhavnagar, Navsari, Surat, Valsad. So these are under RCP 8.5. So this red color shows the higher rate of change, uh, increase of temperature, whereas blue color shows the lower green color. And here also, same in case of minimum temperature also, the you see these in the Kutch region and sorry, Kutch region, Bhavnagar, Ahmedabad, Surendnagar, and this eastern part of Gujarat having a high rate of increase of temperature, minimum temperature, and under RCP 4.5, whereas under RCP 8.5, and only northern part is having. So therefore, we see spatial variation is also there. It is not uniform that the temperature in all the districts are behaving same. This is the case of rainfall, and this is here actually you see in North Kutch also we found the rate of increase. Means the Kutch region is going to have higher rainfall. The rate of increase in rainfall is higher in the Kutch region as well as in South Gujarat. The region which are having highest, lowest rainfall and highest rainfall, they are going to have more rainfall in comparison to most of the is below most of the parts of Gujarat is not going to have very less increase in rainfall. And under RCP 8.5, it is average for all the region except in South Gujarat. Under RCP 8.5, also South Gujarat getting higher, projected to get higher rainfall. Similarly, in the sunshine hours, having in middle Gujarat, this region is going to have um, reduction rate of decrease in sunshine hours in middle Gujarat. This supports in Bhavnagar and this region is going to have less sunshine hours. Now impact studies. These are the climate change projection data we got from IITM, and we formatted the data in to use with the DSET group of simulation model. Most of you may be aware. I am not going to describe anything, but this is most versatile model having a deep simulation, dynamic crop growth simulation model for more than 42 crops. And what we have studied are four crops: cotton, potato, pigeon pea, and sugarcane. And crop grow cotton, uh, potato, crop grow pigeon pea, and cane grow sugarcane models were calibrated, validated with the experimental data collected from the different research stations of Gujarat. And we then sensitivity analysis were also carried out to see the effect of intra-seasonal variability of climate on the crop. And then same models were used to study the impact of climate change on different crops in the different districts of the Gujarat. And one more attempt we have done, how this crop simulation model can be used to predict the forecast the district-wise yield. So that attempt has also been made. I will go one by one. For calibration validation, we have used this experimental data from Regional Research Station Anand for cotton, Main Vegetable Research Station Anand for potato, Pulse Research Station Vadodara for pigeon pea, and Main Sugarcane Research Station of Nosari. And there are different varieties and different periods of available data. Minimum 4 to 6 years data we are used. So some some data has been used for 2 or 3 years. 2 years data has been used for calibration purpose, and then 1 year, 2 years, depending upon the available data, we have validated the simulation model. So here the left side use the uh, calibration of the data and model with the experimental data and over the uh, validated or independent data. This data was used for calibration of the model and this was for validated. Likewise, this is for pigeon pea calibration purpose and validation purpose. So the results of the statistical parameter indicated that uh, these are actually in sugarcane slight differences is there, but in other crops calibration validation was good, and hence these validated model can be used to study. Once the model is validated, it can be used for any purposes. And that's we have used these validated models for different purposes. One is sensitivity analysis, means to study the how the effect of individual parameter. If you change the parameter in the model, input parameter, how it is behaving. For that purpose, we have changed the rainfall and temperature during different period of crop growth. Means for different months, different season or crop growth period, we have changed the parameter temperature. Suppose for different crops. For pigeon pea, suppose we increase the rainfall during July, August, or September. In different months, if we increase the rainfall, what will the effect? If we increase the temperature or decrease the temperature, what will be the effect? So that way, this analysis has been carried out. And this is for, of course, all periods are there, but I am not presenting all the data. Seed cotton yield, effect of temperature on seed cotton yield. You see the, and suppose in July, August, September, I am presenting here. -3, decrease the temperature. We decrease the temperature in the month of July by 3 degrees Celsius and see what is the effect on different two cultivars we have selected. For what is the response change in the yield. So therefore, increasing here the temperature decreasing -1, -2, -3, and then increasing 1, 2, 3. So changing the temperature ±3 degree and in different months, we studied the impact. Okay, what is the impact on percentage change in the yield? So therefore, you see some August, if you increase the rate of yield increase, actually most of the cases, if you reduce the temperature, the yield is going to increase. And if you increase the temperature, yield is going to decrease. That way, all the model, I mean, all the in the different months, but the extent of effect is different in different months. Similarly, the effect of increase in rainfall. If you increase the rainfall in July by 10%, 15%, 25%, if you increase the rainfall during July, so what will be the effect on the two cultivars of the cotton? So you see, if you decrease the rainfall, yield is decreasing. Of course, the varietal differences are also significant in the within the two variety. The response of rainfall is different. And if you increase the temperature, increase the rainfall, the yield is increasing. You see, if you decrease the rainfall, the effect is more reduction in the yield reduction. Where if you increase the rainfall, the effect is less. So therefore, higher rainfall is not going to increase that much yield as the lower rainfall affecting adversely. Similar case is with we have worked out for the pigeon pea. Pigeon pea is long duration crop, and to study different month changing temperature, what is the effect? You see, in June, August, September, October, November, these are the crucial period where the effect of temperature is more. In June, temperature are higher, it is having less effect. So, but a pattern is more or less same. If we decrease the temperature, the effect is um, higher, increase, it has positive effect. If you increase the temperature, it is having negative effect. In the case of rainfall, if you increase the rainfall, yield is uh, increasing. If a rainfall is decreased, yield is decreasing. But in case of temperature, if you increase the temperature, yield is decreasing, and if you decrease the temperature, yield is projected to yield is decreasing or increasing. If temperature is decreased, yield is increased. So this way, slightly from every month to month, slightly the magnitude of effect is slightly different, but the pattern is same. And in case of rainfall, same pattern is there. Increasing rainfall having increasing effect, decreasing rainfall having decreasing effect. Similar as we have seen in the cotton, similar pattern is also seen in the case of pigeon pea. Now, potato potato grown during winter season, and here we see the effect of temperature increase, decrease in temperature having maximum effect on the favorable effect. If you decrease the temperature, the yield is going to increase, and if you increase the temperature, yield is going to decrease. So therefore, same pattern, but the effect during different months, as the effect in of the change in temperature in the month of December is more than that in November and even January. So therefore, for potato, the December temperature is a very sensitive, we can say. And case of minimum also, there may be slightly variation, extent of the effect of increase and decrease of the temperature. But the pattern is more or less same, and December, in this case also, December is found to be most sensitive. Of course, in other month also, January also, it is having a significant effect. If temperature is increased, 15% reduction in the yield is projected. In the sugarcane yield, actually sugarcane is a quite long duration crop, and whole year, 1 year, it is again, but what among the different months, I have given here only for 2 months, which are having maximum effect, April and May. Here in the May, if you temperature decreases, the yield is increasing. Like that, it has been both in summer also. If summers are here, model says that if temperature decreases, yield is increases. Rainfall, in case of rainfall, if again same pattern as we have seen, rainfall if decreases, yield is also decreasing. If rainfall is increasing, the yield is increasing. But the effect of rainfall in the month of June and July, June is most sensitive than August and September. Like that, June and July have more pronounced effect of rainfall on
હા
the.
સરને ખબર
Therefore,
ઓળખે
now
સર હું આવતો જ તો હમણાં બેસવા
impact study, um, impact of how, as
હા
we
હા
have seen, we have calibrated and validated the model.
ચાલ
Then we have worked out the
ના
sensitivity
ના ચાલ
analysis. What is the change of temperature and rainfall during different period of the crop growth on the different crops, and uh, as we have already seen for different crops, and with the experimental data what we have conducted. Now, what impact study means the impact of climate change. Under climate change, it is a composite of all. It is not only one temperature or rainfall, because the temperature, minimum temperature, rainfall, sunshine, CO2 concentration, everything is changing. So what will be the effect of complete climate, which is projected to vary, change over the period of time to 2099? What will be the effect? The projected climate, what we have seen earlier, that has been used and fed input in the crop simulation model. And for different districts, because cotton is grown in most of the regions of the, and then pigeon pea in selected district, potato also in selected. So these are the major districts where the contributed for the yield. So we have studied for different districts. What we see actually, of course, we have seen the temperature is increasing. One sensitivity analysis model also shows that temperature, if a temperature increases, yield decreases. So here the overall yield is decreasing. But another thing that rainfall, if rainfall increases, the yield should also increase. So therefore, this impact is quite means incorporating all the aspects, whether it is even CO2 concentration, sunlight decreasing, rainfall increasing, and rainfall increasing, and increasing temperature. So, but under both the scenario, under RCP 4.5 upper line, whereas RCP 8.5, this is the lower, the yield is going to decrease, and it will be lower in the case of RCP 8.5. And in case of RCP 4.5, the slightly it will be higher than that way. But the trend is same. Both yield, seed cotton yield will decrease. And this is just we have presented for Ahmedabad. Here I have summarized in the particular selected years. Suppose 220, this is the yield, and decreasing. Here the temperature is increasing, and minimum temperature very less increase. Rainfall, of course, very 500, 945 in this year, 700, then again decrease, and then increase. So even you see the rainfall in particular 2099, what we see, rainfall will be medium. And we have seen the effect of rainfall. If a rainfall is higher, yield will be higher. But that is not going to affect the yield. Even though rainfall is double, more than double of the mean value in Ahmedabad, but yield is not going to affect. So that is because maybe because of the distribution of the rainfall, because as we extreme weather events are going to increase, and therefore even if rainfall has increased uh, substantially, but it is not going to increase the yield. It not counteract the effect of adverse effect of the temperature. Under RCP, same thing, same. Of course, rainfall is less, but yield is even quite less than RCP 4.5. This we have also worked for different taluka, different districts where the crops are grown. In case of umbrella, what we see, of course, from up to 2000, you see, of course, both if we have drawn over the period, it is decreasing trend. But if you see critically, over this period from 20 to see about to 50, 60, there is not much decreasing trend. It is fluctuating. Variation is there in most of the cases, even under RCP 5 also, 8.5 also. It is not the umbrella is not going to be that much affected by trend, climate change trend. Variability is there, year to year variation is there, but not after 2060. There is a decreasing trend is there. Overall, of course, a decreasing trend, but you see, it is not seen in this at least next 30 to 40 years in Amreli. It is not going to change. So here actually the rainfall has been projected quite high in the RCP 4.5 also in Amreli district. Actually, of course, fluctuation is also there. You see 800 to 1600, then 600, 14, 15, highly variable rainfall is being projected in different years. But during this year, you see 20, yield is 458, and then it has increased into 40, 543, 60 also 542, then it has decreased. What I told you, up to 2050, 60, the there is not a trend, a decreasing trend in the, it is not going to affect climate change as projected, is not going to affect the cotton yield in the Amreli district up to 2060. And this is Jamnagar. Jamnagar continuous, it is decreasing. There is no, Amreli was quite different than this one. So same pattern trend that is decreasing over the period of time continuously. Here also Surendranagar have some different pattern. Here also you see over the period of quite a fluctuation in the yield as well as not much change. You can't say up to even 2070, 80. You can see more or less it is a same fluctuation is there, year to year variation is there because fluctuation in the rainfall, you see 100, 600 rainfall, then double 1200 rainfall, then 2060 it is projected for 90 only, then like rainfall variation is there, but yield is also increased 260 to 500, 300, then after 260 only really the yield is decreasing trend. Otherwise, up to 2070, more or less, it is a fluctuation. There is no trend, but the yield variation will be there from year to year. Similar, this in Bharuch, trend. Of course, year-to-year fluctuation is less in comparison to cotton yield, but it is continuously decreasing in the both the scenario. And of course, the rainfall has been found to fluctuate from 600 to 1400 1 year, then 600 to 700, 1000, like that. But yield is continuously decreasing over the period of time. Then in Panchmahal district, also more or less same trend. But as we have seen, highly large fluctuation from year to year in the yield of the cotton, but not in the case of pigeon pea. Pigeon pea yield variation, year to year variation in the yield is less than that one. This is potato for Anand district. Actually, Anand, here also it is a continuously decreasing trend. In between 2040 to 2070, 80, it is seems to be constant, more or less constant, fluctuating over the mean. But from year to 2040, it is significantly decreasing trend, and later period also. But in mid century, it is going to be stable potato production. This is in the Banaskantha district, which is having in Banaskantha, we have much more potato production. but the pattern is same. Here initially it is decreasing, but you see during mid-century, mid-century, the fluctuation decrease in the yield is stable. It is only fluctuating over the mean data. Of course, decreasing trend has been observed. And as I told you earlier also, it is even the uh, rainfall has increased, rainfall is increasing, but potato, of course, it is a winter season crop that is not going to be affected. Even rainfall has increased, yield is not increased. In case of sugarcane actually it is a long duration crop, and the effect of climate change, of course, the variation is also very less. Decreasing trend is there in both the scenario. And what we have seen sugar for in Navsari district, of course, it is decreasing trend, but initially for 20 to 30 years period, it seems to be more or less uh, constant, not a significant decreasing trend. Then after that, it is decreasing trend after 2050 or so. Sugarcane in Surat district also more or less same pattern during initial period of 20-30 years. The yield is going to be more or less same, but after 2050, it is decreasing. So this way we have projected the change in different projected yield in different districts of the Gujarat. I have given graph for only selected district, but we have worked out for the all the major districts which are producing the crops. Now, one another attempt we have made how to use the crop simulation model output for predicting district-wise yield. Actually, simulation models are location specific. We are calibrating, validating model with the experimental data. The experimental yields are quite different than the district yield. District yield is over the different management practices, different varieties, and all together soil and over the area. So climate-wise also variation over the district, but soil and variety management practices. But we have tried to uh, use, we have data of weather and soil and we have calibrated the model. And we try to correlate what is the relation between the simulated yield and the district-wise reported yield. And we develop the relationship between these two, and that we can use the correction factor to predict or forecast the yield of the district-wise yield using crop simulation model data from your station. So that way we have 10 up to we have used the 10 to 15 years of district-wise past data and weather data and develop the relationship. And up to 2015, we have used for develop the relationship, and for next 3 years, 2016 to 2018-19, 3 years data has been used for validation of the model forecast. It means how much the simulated yield. We have developed the relationship and we apply the relation using crop simulation output, and then you can predict the forecast the district-wise yield. So here you see this is the simulated versus observed yield, and we develop the relation. This is in case of cotton for Ahmedabad district. Here this is in case of cotton Amreli district. Here see the R square is 0.94 in relation between the simulated by the model and reported. Observed means reported by the district yield reported. So therefore, we have developed the relation and our simulation output R square has been quite satisfactory. You see here the different districts is summarized, and R square 0.9, 94, 93, 99, 90, 86. So therefore, means in different districts, of course, variation is there, but this equation, we have developed this equation, and these equations can be used for predicting the district-wise yield. Here, X is your model output for a crop simulation model output, and using the validated model, use the and use the weather data of each station of that district and simulate the yield, and this yield will be, and apply this equation, you will get the forecast for the next, predict the, and therefore we have predicted, means for Ahmedabad for 2016, 17 and 18, for 3 years, as I told you, for different districts we have used that equations and predicted. Here this is observed reported yield, and here this is the simulated yield by the model, and rate of the error is the difference is in all the districts. You see, it is less than 10%. I mean, highest it was somewhere 9% I saw. Uh, so, but it is the Junagadh, it was 9%. Otherwise, uh, the error percentage is less than 10, and therefore we can use this simulation output models for predicting the district-wise yield of the cotton in different districts. Next, similar work has been done for pigeon pea also. Of course, the relation is not that much satisfactory as we saw with the cotton. A cotton model has worked very nicely. But here also, you see that in different districts, 0.8, 0.6, 0.6, 8, 7, 9, 4, 90, 0.75. So it is also highly significant R square values are there. So therefore, in case of um, this is just a, for example, Banaskantha and Panchmahal district here. I have presented a graph, but we have worked out for all the districts, and these equations can be further used to predict the district-wise yield of the pigeon pea in these districts. And we have validated for the 3 years independent data. And here, of course, Banaskantha, some 11% error is there. But in most of the, except 1 year, and all the other years, the error percentage is less than 10. And therefore, this this model can be used, simulation model output can be used for predicting the district-wise yield of the pigeon pea. In the same way, we have worked out for potato. Potato, only 5 districts are there. Here, of course, the R square is not that much high, only 0.5, but although it is significant, 3.6 it is less, 0.61, 0.62, 0.77 R square value. In 3 districts, it is quite satisfactory, but in 2 districts, not much. And here we see Anand, a lot of variation, fluctuation, variation is there. But overall, for other districts, the model are working good. And we have used for validated with the next 3 years data. And what we see, the here slightly 11% and 11% 1-2 cases are there. Otherwise, in all other years, the simulated yields are quite matching with the observed reported yield. and error percentage is very less. So therefore, this tuber yield of potato yield can also be predicted using the simulation model. Sugarcane, as I told you, lot of is a long duration crop and effect of temperature and rainfall variation in different months was not except 1 or 2 months. Other month effect of weather parameter was very less. Uh, but the simulation as a whole, the also here R square is less 0.5 only. But no, sorry, not good Kharuch, no, sorry. But in other Surat, Tapi, and Valsad, this model can be used. And we have to see, find out what is the, again, we have to check what is the reason for this R square in these two districts. So that even in other districts, it can be safely used for predicting the district-wise yield. Here, during validation period, of course, there is not much, even R square was less, but during validation period, there is not much differences in Bharuch and nursery also. So this type of analysis shows that our uh, simulation model, we can simply, there are, for GIS, different approaches are there, which can integrate simulation output with the soil and other management practices and to try to predict the district wise yield. But this is the simple approach that using the simulation output, how can you predict the district wise yield? So as a summary, I can summarize now that what we have used for RCP climate change projection under RCP 415, 8.5 for this period, and minimum temperature has been projected to increase in the both scenario. Rainfall is projected to increase marginally, while sunshine duration is to decrease in almost all the districts of the Gujarat. The rate of change was found to differ among the districts. However, the rate of increase decrease was higher under RCP 8.5 in comparison to RCP. DSET model was calibrated and validated, and this RMSE error, this parameter indicate that model is satisfactory validated. And then sensitivity analysis we carried out for increasing, decreasing temperature by 3 degree and rainfall by 10, 20, 15 and 30% on different crops. The increase in temperature and cause decrease in the yield and vice versa. Whereas a rainfall, increase in rainfall is found to be favorable effect. Again, the magnitude of effect was found to vary with the crop, season, variety, as well as the extent of the change in the parameter. Impact of climate change and yield of different crops are projected to decrease over the time under both the scenario. The rate of change differed with the crop location and climate scenario. District-wise, yes, I concluded the validated models can be used for predicting the district-wise yield using the crop simulation model output. Because under the validation period, also the error percentage was less than 10. Therefore, this model can also be used for predicting the forecasting the district-wise yield. Okay, thank you. Hello. Any question answer? Manoj? Yeah. Hello. Hello. Hello, Manoj.
Okay, sir, we have one question, and the question is about what does it really mean by RCP 2.5, 4.5, 6, and RCP 8.5, and what is the radiative forcing in this?
Actually, RCP, we have seen a representative pathway, concentration pathway. Earlier, IPCC used to give different scenario, A1, B1, depending upon the what assumptions means develop. If you are developed countries, you are controlling the emission of the greenhouse gases, and which are developing countries where new industrial developments are there. So therefore, their technology is not that much to cope up with the control the greenhouse gas emission. But incorporating all these factors means whether if you control all the emission, greenhouse gas emission, and different scenarios has been given. RCP 2.6 means if you, whatever, we have seen, the carbon dioxide concentration is increasing every year. But if you take altogether all the gases, not only carbon dioxide, because we have seen different gases are there having different effect. So considering all the gases, emission of all the gases, if we assume that gas concentration of gases are increasing, and they will have effect on the warming of the radiative forcing. What do you mean? That because of the concentration of these gases, how much heating effect will be there in the atmosphere. So assuming that one, suppose in 2.6, it is assumed that by 2020, maximum concentration of carbon dioxide will be there. Here, you see carbon dioxide concentration equivalent, ppm. If suppose 2020, it is a maximum, therefore, thereafter it will decrease. Means we control all the emission of the greenhouse gases. After 220, there won't be any further increase. Whatever rate of increase is there as of now, it will continue the same or it will decrease further. Under that assumptions, this is the RCP 2.6. And thereafter, the emission declining substantially thereafter. And after 220, the emission rate will decrease. So this is the RCP 2.6. Similar case, RCP 4.5 means it is assumed that by 2040, 50, the maximum concentration of the peak emission, the rate of development, what we are saying, because of rate of development, we are the emission of gases are more. So if you control all the emission by 2040 and 50, then and thereafter the decrease will be there. Then that type of scenario has been termed as a emission RCP 4.5. And under RCP 6, same thing. It will be peak will attend in 2080, and under RCP 8.5, there is no control. Whatever as of now, rate of increase of greenhouse gases are there. If this is go as whatever has been as of now, the same thing, if without any control, without any measures, if you go on taking this one, this scenario will be obtained. So because of this, under different assumptions, if you control the greenhouse gas emission by this way, what is the minimum? So this is the maximum efforts one should have taken to minimum effect on the change in the climate and the impact on the and different. So likewise, different assumptions are there. Under this, what is just we have seen, because of even under RCP 2.6, if you control by 2020, even then temperature will slightly increase up to 50, and then thereafter decrease will be there. But if you don't control emission of greenhouse gases, then it is going to continuously temperature is going to increase, and climate change also increase. Radiative forcing means that same thing, that because of these gases, as I seen shown, that this is the radiative forcing, means greenhouse gases are there, they absorb, they absorb the or long wave radiation, and because of this atmosphere is being heated, as these are greenhouse gases, and what is the effect, what is the process taking place in the greenhouse effect, and these are the greenhouse gas, and what is they have a radiative forcing means effect of concentration of these gases, how much heating effect and they will give on the climate system, climate, how the climate will be changing. This much heating effect will be there. So therefore, this is the radiative forcing heating effect of the greenhouse gases, tropospheric ozone also, water vapor also have some stratospheric water vapor also have heating effect, whereas vegetation has a cooling effect, aerosols, cloud formation, all these things take place because they have cooling effect. Again, so total because of human man-made system, total anthropogenic causes, that is causing the increase in greenhouse gas mainly, these are and having impact on the global heating, warming, radiative forcing, that causes the heating in the atmosphere. So this is the any question?
Okay, there are no more queries. So thank you very much, sir, for sharing your knowledge and also the findings, exact findings for different crops on Gujarat, and for giving us opportunity to learn from you. Thank you, sir. Now we are closing this session. Tomorrow morning at 10 p.m. 10 a.m. we have session on different risk scenarios for agriculture, and resource person will be Dr. Atri.
Okay, thank you.